Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Virtual work. For this problem, we want to determine the angle theta. We'll apply the virtual work principle to solve it. Okay? We have this first, there's a first year, there's a first year P. Okay, so there's a first year P. Okay, is P and is given, this value is given as 800 Newton. And let's call this place A, and let's call this 0, sorry, O. Okay, and the length here, oh, let's call this place C, and call here D. Let's call here B. All right. And there's a spring here. So there's a spring force there. So let's call it F subscript S. All right. This is theta, which we want to look for the angle theta. I want to look for. Now we'll consider this the virtual work due to this force P. Let's say there's a small virtual displacement here. Let's call it dy subscript A, and there's a small virtual displacement due to this the spring force. Okay, let's call it dy subscript 0. Sorry, dy subscript O. Okay, why that due to the force P dy subscript A. All right, so all this length they are given. Okay, let's this place be let's call this place B. No, let here be let's call here C, and let here be E. B O O D O C O, so O C E A. They are all given. Okay, the lengths are given. Okay, as 1 meters each. All right, and the virtual displacement, this one will come here. All right, so we are going to have a positive virtual work uh, with respect to the force P, and for this spring force, we're going to have a negative virtual work. So that the spring force, we consider this force, the spring force is going to give us uh, K, which is the spring's stiffness times the position vector specifying the force, which we call that, so that we can just look, find what this will give us. This will be the same thing as okay, sine theta. If you look at it carefully, since all those BO, OD, they are 1 meters, they have length of 1 meter each of them. All right, so we are going to have that. So if we decide to differentiate y sub 0 with respect to theta, and just make the theta sub 0 the surrogate of the formula, we are going to arrive at cos theta d theta. Okay, cos theta, going to arrive at cos theta d theta. Okay, now having done that, we can look for the consider this force P, that point, the position coordinate here. Let's call it y subscript A, considering force P. Here we have force P there, that point at A. We are going to have it to be equal to, now considering our datum, we should know that we are taking our datum from this point here, BD. Okay. Okay, so if we consider this one, then we are going to have it to be 3, okay, sine theta. Okay, if y sub 0 gave us 3 sine theta, then this one is going to give us 3 sine theta. Okay, from the diagram given there, you can figure that out. Okay, okay, so we can just differentiate this straight ahead and get our answer. So if we differentiate this just the way we did earlier on, differentiate this with respect to theta and just make the y subscript a the surrogate of the formula, we are going to arrive at cos theta the theta, sorry, 3 cos theta the theta. Fine. Now we can now apply the equation, okay, for the virtual work. So if we do that, we're going to have this. So we have the u is equal to 0. Now you can see that for the spring force, we are going to have a negative virtual work. Okay, so it's going to give us. We already know that F sub s is k times y sub 0. Okay, so we can just plug that in directly. If we do that, we're going to have it to be minus k sub y 0. Then the virtual times virtual displacement y subscript 0. Sorry, this is not subscript 0, subscript o. Okay, all right. So and we have for the other force there, the 800, which is p. For p is going to give us p the y subscript a. So we can just plug in values. To plug in values, we are given k to be 6 kilonewton per meter. So we're saving at 6,000 newton per meter. Okay, then just which is k, then sine theta for y subscript o. Then the other one is the y subscript o is cos theta the theta. Okay, now we also have our p, which is negative, it's coming down, times the y subscript a, so which is 3 cos theta, 3 cos theta the theta. So everything here is equal to 0. So if you can see that the theta is common to the parts we have there. So we can just bring out the theta out. And we're going to have this minus 6,000 sine theta cos theta. Sine theta cos theta. All right, now plus, of course, that negative sign there will change it to negative. So we're going to have minus 2,400 okay cos theta. So of course this is not equal to 0. So we can just solve for the other one. If you solve for that one, we are going to arrive at sine theta sine theta to be equal to 2400, okay, over 6000. Now we can just find the arc sine for the value that will be gotten from 2400 over 6000, and we're going to arrive at theta to be equal to 23 23 0.58 degrees. So this is the magnitude, okay, the value of theta, okay, the angle.